Hi and welcome to my channel. My name is Tobias and today we're going to look at the difference of squares, of two squares. So if we've got this expression, a plus b times a minus b in parentheses, then we can use this picture down here to see how we could do it. So we take the first term in the first parenthesis and multiply it onto both terms in the second parenthesis, and then we do the same with the second term in the first parenthesis, and then we multiply it by both of them in the second. So let's have a look. We say a times a, that's a times a, this expression. Then we say plus a times minus b, that's plus a times minus b. Then we say plus b times a, that's this expression. And then we say plus b times minus b, that's plus b times minus b. If we multiply a positive number by a negative number, or plus multiplied by a minus, then that equals minus. So we end up with a times a, that's this expression down here, this term. Then it's minus a times b, because plus and minus equals minus. Then we say plus a times b. The order in which we multiply is irrelevant, so a times b is the same as b times a. Tried with real numbers, like 2 times 3 is the same as 3 times 2. So we get this expression of this term, and then we get plus and minus once again equals minus. So we say minus b times b. And then we end up with a times a, that's a squared, minus a times b plus a times b. These two will negate each other because we've got the same expression, a times b and a times b. This has got a negative sign in front of it, this has got a positive sign. This will negate each other, so we end up with a big zero for these two. And then we end up with minus b times b, that's minus b squared. So if we've got a difference of squares, then we end up, and it's a plus b times a minus b, then we end up with this expression, a squared minus b squared. So we just look at the first term, square that one, and then we say minus, and then we take the second term and square that one. So let's see that with a couple of examples. This time, instead of a and b, I've used s and t just to show that that's the same procedure. So s times s, that's this term, plus s times minus t, that is this term, plus t times s, that is this term, and plus t times minus t, that would be this term. Once again, plus multiplied by minus equals minus, and plus multiplied by minus equals minus. So we get s times s, that's just the same term here, minus s times t for this expression or this term here, then plus t times s is the same as s times t, and then we say minus t times t, because plus and minus equals minus. And we end up with s squared, because s times s is s squared, and minus t times t is minus t squared. These two will, like the first example up in the beginning, negate each other, because it says minus s times t plus s times t, and that will equal 0 all in all. So we end up with s squared minus t squared. Had we just used this formula right here, we could just have said the first term squared, that's s squared, minus the second term squared, that's minus t squared. So that would be by using the formula up in the beginning up here. Now we use it with another example. This time it's both letters and numbers. So we say x plus 2 multiplied by x minus 2. And we just do the same. We say x times x, that is this term, plus x times minus 2, that would be this term, plus 2 times x, that is this term, and plus 2 times minus 2, that would be this term. Once again, plus and minus equals minus, so we get minus in front of this expression. And we like to get the numbers in front of letters, so we just reverse the order here. So we say x times x minus 2 times x plus 2 times x, and plus and minus once again equals minus, so it's minus 2 times 2. X times x, that's x squared, minus 2x plus 2x, that negates, they would negate each other, so that equals 0. And then we get minus 2 times 2, that's minus 4. So this sum of a difference of squares would equal x squared minus 4. If we had just used the formula in the beginning, we could say the first term squared, that's x squared, minus the second term squared, that's minus 2 squared, that's minus 4. That was an example with both letters and numbers. Let's have a look at the third example. This time we've got terms with both numbers and letters. So 2 times x plus 3 times y in the first parenthesis, and in the second it's 2 times x minus 3 times y. And we just do the same once again. 2 times x times 2 times x, that is this first term here, plus 2 times x times multiplied by minus 3 times y. That is this expression, this term. Then we say plus 3y times 2x, that is this expression here, this term, and plus 3 times y minus or multiplied by minus 3 times y. That is the last term, the last expression. We like to get the numbers in front and the letters in the back, so we make the order a little bit different here. So 2 times x, we've just mixed it up a little bit with the numbers in front and letters in the back. Plus and minus equals minus, so that's minus 2 times 3 times x times y. That is this expression. We do the same here. Plus in front and the numbers in front, and we just let the number 2 be before the number 3 to see that it is the same term here, just with minus here and plus here. So 2 times 3 times x times y, that is this expression up here. And in the end we've got plus and minus once again, that equals minus 3 times 3 times y times y. So we get this term, this expression. And 2 times 2, that's 4, x times x, that's x squared, minus 2 times 3 times x times y is equal to this, minus 6xy, plus 2 times 3 times x times y is equal to plus 6 times xy, and minus 3 times y is equal to minus 9y squared. They negate each other in the middle here, so they equal 0. And we've got 4x squared minus 9y squared. That is our result of multiplying these two parentheses. If we had just used the formula in the beginning, we could have set the first term squared, so we have to use parentheses around 2x squared minus, and then the second term squared. And if we've got a term with both numbers and letters in parentheses squared, then we have to use the square on both, or the power of 2, both on the number and the letter. So 2 squared, that's 2 squared, times x squared, that's x squared, minus 3 squared times y squared. And we end up with 2 times 2, that's 4, and x squared is just x squared, minus 3 squared, that's 9, so minus 9 times y squared. So the same expression here, we really calculated and had to do the entire procedure. If we had just used a formula up in the beginning, we could have gotten this result much faster. The last one, or that was the last example, number 3, with both numbers and letters. Well, thanks for watching. See you next time. Bye bye.